Okay, so let's continue discussing about the diodes. So the diode, or the other term for this device, is called a PN junction device. It's an electronic passive device that conducts current only in one direction. So in short, ang tawag sa kanya is a unilateral device. Uni, ibig sabihin isa lang, lateral, ibig sabihin yung direction. One direction lang yung pinagko-conductan niya. Okay? So yung two terminals ng diode is the anode, which is yun yung nasa P region, and yung nasa N region is yung cathode terminal. Okay, so sa diode, yung anode is the positive, hindi ko na nalagay dito. But anyway, pagka-upload ko is i-edit ko naman. So yung anode dito is the positive and the cathode here is the negative. Okay? So nabanggit dito is yung direction ng kuryente, no. So kung maalala natin, mayroong two types of current flow. No? The first type is the conventional current flow, and the second type is the electron current flow. The conventional current flow is the current flows from positive to a negative, or from a higher potential to lower potential. Okay, yung potential ibig sabihin voltage. So the electron current is vice versa, no? From lower potential to a higher potential naman. So, sir, ano ba yung gagamitin nating standard? Yung conventional current. Okay, so, kada magsosolve kayo ng circuit, okay, lagi nyo gagamitin yung conventional current. Okay? So, our main standard for every circuit solution is conventional current. Okay? Next, i-recall ulit natin yung diode operation. No? So, na-discuss ko na naman to last video. No? So, in order for the diode to conduct current, it must be forward bias. Okay, yung forward bias or forward biasing is the process of supplying higher voltage on the anode terminal than on the cathode terminal. So, the voltage across the diode, no, must be greater than or equal to 0.7 volt. Okay, in order for the current to flow. So, the other term, no, for the barrier potential or yung 0.7 volt, no, for silicon, ito yung knee voltage. Okay, so either knee voltage, barrier potential, yan yung mga tawag sa 0.7. Okay? So, it is the minimum requirement voltage across the diode in order for it to conduct current. So, for silicon, 0.7 volt, for germanium, 0.3, and for gallium arsenide, 1.3 volts. Okay? Next, mag-simulate tayo ng diode, no. Pag-aralan naman natin ngayon yung behavior ng diode, no, with the different voltages. So, mag-start tayo kay 0 volt, and then i-increase natin all the way to 1 volt. Okay? So, tingnan natin ano ba yung behavior ni current across the diode. So, na-simulate ko na to sa multi-sim. And lagay ko dito yung different kind of voltages na ina-apply ko dun sa voltage. No? Nag-start ako kay 0.1 volt. Ito muna yung ina-apply ko sa diode. And then, nag-increase ako, nag-increment ako by 0.2. No? From 0.1, 0.3 volt, 0.5, 0.7, 0.9, up to 1 volt. And ito yung binibigay sa aking kuryente. No? So, from 0.1, yung current sa diode is 26 nanoampere. So, habang ini-increase ko yung voltage ng 0.2, 1.5 microampere, 72 microampere, 4 milliampere, 170 milliampere, and yung maximum natin is yung 1 volt, which is 1 ampere yung current across the diode. So, madaling tingnan, no? Pero, tingnan nating maigi ano ba yung nangyayari dito, no? Particularly, pagka nag-exceed tayo sa 0.7, no? Kung mapapansin natin dito, no, habang nag-i-increase tayo from 0.1, 0.3, 0.5, 0.7, yung kuryente sa diode is hindi nagkakalayo. No? Kung mapapansin natin dito, no, 26 nanoampere, 1.5 microampere, 72 microampere, 4 milliampere, up to 0.7 greater than nung nag-apply na ako ng 0.9, no, ang laki na nung ginump niya. From 4 milliampere, nag-jump siya, no, papunta sa 170 milliampere. So, nagdagdag ako ng 0.1 volt, naging 1 volt. Ang laki na nung ginump niya, no? From 170 milliampere, naging 1 ampere na siya, no? So, ano yung nakikita nating behavior dito, no? Pag pinalat natin to, para siyang exponential. So, observe that as the value of the voltage, no, from 0 to 0.7, yung increase ng kuryente maliit lang. Ito lang, maliit lang siya, no? Pero as the voltage exceed 0.7, the value of the current increase gradually, exponentially. Okay? So ngayon, ito ngayon yung VI characteristic ni diode sa forward bias. Ibig sabihin, yung ina-apply nating voltage is positive, no, from 0 to a positive voltage. What if naman ang i-apply kong voltage across the diode is from 0 to negative? Or in short, i-reverse bias naman natin ngayon. Okay? Bago tayo pumunta sa reverse biasing, no, in practice kasi, hindi natin ini-exceed ng 0.7 yung ina-apply sa diode kasi masisira yun. Okay? Kaya normally nilalagyan ng limiting resistor. No? Ito, nilalagyan ng limiting resistor. So, pagka nakakakita kayo ng diode circuit, lagi kayong makakakita ng resistor, no, in series with it. Kasi iniiwasan nating mag-exceed ng sobra-sobra sa 0.7 eh. Ng 0.9 pa 1 volt, masasabog yun. Okay. I-try nyo sa bahay, no? Bumili kayo ng LED na I think piso lang naman ata yun sa electronic store. No? Huwag nyo lagyan ng resistor and then applyan nyo ng mag-start muna kayo sa 0.5, 0.7, 0.9 up to 1 volt. Sasabog yun. Hindi naman totally sasabog talaga siya na parang Hiroshima bomb, no? Kasi maliit lang naman yung kuryente dumadalo dun. Pero puputok yun. No? Mangangamoy yun. No? So, ganun lang yun, no? Lagi kayong maglalagay ng resistor, no? In series with the diode para malimitahan natin yung current na dumadaloy sa diode. Okay? So, ngayon, balik tayo, no? I-reverse bias natin ngayon si diode. Ayan, I think hindi ko pa rin ata nasabi to, no? Different diodes has different knee voltage, no? For example, 0.7 is the ideal voltage or the nominal voltage or the average voltage. But in real life, hindi naman talaga exactly 0.7 yun. Nagmamanufacturer ng mga for example, LED lights. Hindi naman saktong 0.7 yun eh, lalo na pagka iba-iba yung kulay. Iba-iba rin yung knee voltage nila or yung barrier potential, no? Minsan 0.6, 0.65, 0.8. Makikita nyo sa specification sheet ng isang diode. Okay? So, yung 0.7 is hindi ideal yun. Baka kasi magtaka kayo na bibili kayo sa isang electronic store, makita nyo yung specification sheet. O sabi ni sir, 0.7. But ito, 0.8. O hindi nga. Kasi in real life, hindi, almost equal lang sila sa 0.7. Okay? So, ngayon, i-reverse bias natin ngayon si diode, no? So, if the voltage across the diode is less than 0.7 volt, ang tawag doon is reverse biasing. Okay? So, ngayon, i-simulate ulit natin, no, yung diode with the same circuit dun kanina, no, may voltage source, mayroong diode, and then mayroong ammeter na nakaseries. Okay? But this time, hindi natin i-increase ngayon yung voltage source. I-decrease ngayon natin siya from 0 volt to negative 101 volt. May putal pa, no, na 1, di na lang ginawang negative 100 volt. But anyways, ito yung table, ito yung mga binigay sa aking values na current, no, from 0, obviously walang current na dadaloy, 0 ampere. So habang nag-a-apply ako ng voltage across the diode from 0, so negative 20, merong binibigay na negative 5 nanoampere, negative 40, negative 4.3, nag-i-increment ako ng negative 20 volts. So negative 60, negative 4 nanoampere, negative 80, negative 3 nanoampere, negative 100. Ayun, na kung mapapasin nyo dito, no, ang laki na nung ginamp niya, no, from negative 3 nanoampere naging negative 100 microampere. Meron ding yung parang kanina sa forward bias, no, nung nag-exceed tayo sa 0.7, naging 0.91, ang laki na nung ginamp exponentially. Actually, ganito rin yung behavior niya, no, pag nire-reverse bias natin. So, graph natin to para mas ma-interpret natin. So, as we can observe, no, very small negative current is flowing backward. Ito yun, from 0, negative 20. Ito, maliliit lang, no? 0, negative 5 nanoampere, negative 4.3. Magkakadikit lang. Okay? Technically, this current is negligible and almost equal to 0 lang. Kasi, nanoampere is, hindi naman yan usable talaga in real life. Ang nanoampere is considered as 0. Okay? But, as we further increase the reverse voltage and reach a certain reverse voltage value, ito yon, kung napansin nyo, ito yung nag-jump siya, no, from From negative 3 nanoampere, naging negative 100 microampere nung nilagyan natin ng negative 100 volt. Ang laki nung ginamp niya, di ba? So, ito yung sinasabi niya. So, as we further increase the reverse voltage and reach a certain reverse voltage, in short, for example, yung kanina, from negative 80 to negative 100, the reverse current will drastically increase. Okay, ang tawag natin dun sa voltage na nag-exceed tayo dun, or yung reverse voltage na in-exceed natin, and then naging gradual yung pag-increase nung reverse current, ang tawag dun is the reverse breakdown voltage. Okay? Or VBR. So, yung reverse breakdown voltage or avalanche breakdown voltage, ito yung minimum reverse bias voltage that when exceeded, a large reverse current will flow through the diode, which will eventually damage it. Okay? So, masisira yung diode. So, obviously, hindi usable ang reverse voltage. Okay? Ang ginagamitan lang, ang purpose lang ng actually, may i-discuss ko yun no? Pero hindi naman talaga 100% walang purpose yung reverse breakdown voltage. So may certain type of diode na tinatawag na Zener diode. Ito yung design para sa reverse breakdown voltage. Pero pagka ginawa mo to sa isang normal diode lang, masisira yun. So, sa isang rectifier diode or normal diode lang, which is ito yung dinidiscuss natin ngayon, para mag-operate siya ng maayos, forward biasing lang yung ginagamit natin. No? Pag reverse bias, hindi. Walang purpose yun. Walang sense yung diode. No? Okay? So, ito yung, ulitin natin, it is the minimum reverse bias voltage that when exceeded, large reverse current will flow through the diode, which will eventually damage it. Okay? So, yung seatwork dito, i-solve ko na lang to sa next video. But yun lang yung kabuuan ng topic ng diodes, and sana may naintindihan kayo no, from the basic materials, from extrinsic semiconductors, from P type to N type pinagsama natin, naging PN junction, and then the concept behind it, kung paano nag-ooperate si diode, paano ba nag-flow yung current across the diode, ano ba yung specific potential na i-apply ko sa diode para mag-flow yung current across it. So, na-discuss ko na dun sa previous videos, including this. And sana marami kayo natutunan. And that's the first part of the diode. So, in the next video, solve na tayo. No? Ngayon kasi is more on concepts and theory behind the diodes. No? So, ngayon, solve naman tayo ngayon. No? Iiralin naman natin ngayon yung analytical thinking natin or yung critical thinking skills natin for solving electronic circuits. Okay? So, as always, thank you for listening and God bless.